Hello and hello, what's up to you all, Mindsetters? It is a lovely Monday or 2 p.m. day. It is Mindsetters Maths Monday with me, AB, and Natasha. I hope you had a great weekend and share with me what were you doing today at school on your maths class. I just want to find out and then we'll chat later on. But Natasha, how are you?
I'm very well, thanks, AB. How are you today?
I'm doing well, thanks. I'm all good. My voice is good. I'm on top of my game.
Good, good. So we can hear you today.
Yeah, you can hear me. I can just project my voice nicely. So otherwise, how was your weekend?
My weekend was great and ready for today's lesson, Mindsetters, grade 10s. Today we're revising trigonometry. It's that time of the year again. Everyone's revising, hey?
Everyone is revising and panicking at the same time. You know, they were watching even the revisions over the weekend. I could see and tell on the page that everyone is like on their study tips and they are working so hard, which is good. That's what we want. And what are we doing with them today?
As I said before, we are revising trigonometry. We have done this section in detail if you were paying attention during the term, but obviously everyone needs a little bit of revising, a little bit of reminding of the specific sections that you need to pay attention on for your exam. So that's what we do.
That's more like the scope they're always asking for, hey? Well, guys, better listen today. Pay more attention because we're here to help you. And if you're struggling, chat with me on facebook.com/learnextra. Like our page, share the page, and tell everybody, your friends, your classmates, your street mates about Mindset Learn Extra and how we can help them and how you can also add a value by helping other Mindsetters on the page. Also on Twitter, follow us at Learn Extra. We love following you guys and we love hearing from you guys. If you're enjoying the show, if you're asking some questions, take those questions and then answer you. But remember, we also have some links for you already. They're on the page. Links to the test yourself questions, whereby if you answer those questions correctly, most of them, and get them right, you stand a chance of winning this awesome Casio calculator. I'll be announcing our last week's winner later on the show. But now, check your notes on facebook.com/learnextra. It's two options. It's the viewing option and the download option. Otherwise, Natasha will also tell you more about the challenge question.
All right, okay, guys, before we get to the challenge question, just to let you know exactly what sections we're going to be covering and what sections we're going to be revising. Today we're going to look at two-dimensional problems, trig ratios on a Cartesian plane, and trig functions. Okay, so those are the specific sections we will be revising. And then, as AB said, just a reminder on your challenge question. So you can all attempt this and let us know how you do, what your answers are. Okay, it says from a window in a building on one side of a street 40 meters wide, the angle of elevation to the top of the building across the street is 30 degrees, and the angle of depression to the foot of the building is 28 degrees. Calculate the height of the building on the opposite side of the street if both buildings lie on the same horizontal plane. Now, guys, with this one, you just need to remember, it's a lot of words. And remember, in maths, we don't so much like words, we like numbers. So you need to take this sort of word-looking problem and convert it into something that can make mathematical sense. And what's going to assist you in this specific trig problem is draw a diagram. Okay, you're going to need to draw a diagram to understand what are they talking about. Put in your angles of elevation, put in your angles of depression, and let's see how you get on with this later on in the show. All right. So let's get straight into today's lesson. Remember, we are revising. So revising is all about doing questions, putting examples out there, all right? We've already covered all this work in detail. We've done it on the show, and I'm sure you guys have done it at home as well. So I really just want to supplement what you've already learned, and we're going to get straight into the questions, show you the kind of questions. Now, these are not going to be the exact questions that come out in your test, of course not, but they give you an idea of what you can expect and what you should be preparing towards. Okay, so the questions that I've chosen for today's revision lesson are very commonly asked questions. Okay, so in question 1, we are given that sine of theta is equal to 0,4. Theta is an obtuse angle. Remember, obtuse, that means theta is less than 180 and greater than 90 degrees. In other words, that falls into quadrant 2. Okay, so as you go along, you get tips from your question. That's the first tip. Theta is an obtuse angle. They say without using a calculator, obviously very important. If you're given an instruction without using a calculator, do not use your calculator because you will not get the marks. Okay, find the value of A cos theta and then B root 21 tan theta. All right, again, a very, very common question. So we've packaged this, we've broken it down a little bit. We know that obtuse means I'm dealing with an angle that lies in quadrant 2, right? That, again, is further affirmed by the fact that sine of theta is equal to 0,4. So sine of theta is a positive angle, theta is obtuse. Where does that happen? We know that using our cast diagram, sine is positive in the second quadrant, and theta is an obtuse angle in the second quadrant, right? So we're going to draw what we call a Pythagoras type triangle. In other words, it's going to have a 90-degree perpendicular drop. I just want to get my correct pen here. There we go. All right. So we're going to extend from the origin. We draw the terminal ray, and then we drop a 90-degree to the x-axis. That's our perpendicular. All right. And then we know that that's the angle there. That's theta. All right. Okay, so they're telling us sine of theta is 0,4. Remember, this is without a calculator. We can rewrite that as sine of theta is equal to 4 over 10. And we can further simplify that to 2 over 5. Okay? Now remember, from definition, sine is equal to opposite over hypotenuse. Okay? Or if you're using x, y's, and r's, this is the same as y over r. All right? So in my triangle, I'm going to say, well, sine of theta is 2 over 5. Therefore, if theta is my reference angle, I know that the opposite side is going to be 2 units, or the y value, the vertical side, is going to be 2 units. And then we know it's opposite over hypotenuse, or y over r. Therefore, the radius is going to be, or the hypotenuse is going to be 5 units. Now remember, when you're dealing with these kind of questions where you've got to make use of this triangle and fill in the information and then get a third side, that's often what would happen. You'd be asked to do this question without a calculator, and you'd need to draw the diagram in order to answer it. What they would do is we would give you 2 sides and you'd have to determine the other side. How do you do it? Well, we've got a 90-degree triangle, so we can use Pythagoras, right? So what's the unknown here? I've got y, I've got r. So I need to find the value for x. So I can say from Pythagoras, x squared plus y squared is equal to r squared. I know that the radius is 5 and the y value is 2. So therefore x squared is going to be 5 squared minus 2 squared. So I get 25 minus 4, which is 21. So therefore, x squared is equal to 21. So x must be equal to plus or minus the square root of 21. Remember, whenever you take the square root, it's always plus or minus the root. Now we are in the second quadrant. We are on the left-hand side of the axis. So therefore, we know that all our x values to the left of 0 are going to be negative. All right. So therefore, the x value at this point is negative root 21. Okay, so the x value at that point is negative root 21. Now guys, it doesn't come up in this question, but remember, the x value, so the coordinate there is going to be minus root 21 and 0. However, the distance from the origin to that point is not negative root 21 units. It's just root 21, okay? Because remember, your distances can never be negative, okay? So when we're putting that negative in, we're actually referring to the coordinate. We're not referring to that distance, okay? Now, first part A says find the value of cos of theta. We know from definition that cos of theta is adjacent over hypotenuse, or the same as x over r. All right, so I go straight to my diagram. I say, okay, well, cos is going to be adjacent over hypotenuse, so therefore it's going to be minus root 21 all over 5. All right, That's the first part. Part B, once you've got the diagram, it's really easy. We just read off straight from the diagram. In place of tan theta, I go to my diagram. I look for the ratio for tan of theta opposite over adjacent, or y over x. So it's going to be 2, and this is not a negative, this here was a positive 2, remember, that was the y value. So it's going to be 2 over negative root 21. Alright, we can simplify this. Root 21 and root 21 cancelled. 2 divided by negative 1 is just negative 2. Okay. Right, guys, so that, as I said, it's a very, very common type of question where you are given a ratio for one of the trig ratios and you are asked to then find the other values without using a calculator. A very, very common concept. If you have any issues with this concept, please let us know, but maybe this is a good time for us to have a quick break before carrying on with questions.
Yes, indeed. Well, Mindsetters, let me tell you also about the Nokia Mobile Mathematics, which is a cool app that you guys can challenge yourself and challenge one another on. Well, it's all about mathematics, so you can also go over what we're doing today on that app. More details are on Facebook, and your code as Great Hands is 2FB5. 2FB5. More details are on facebook.com/learnextra. See you after the break. Welcome back, awesome Mindsetters. Now, on the page, we do have the Test Yourself questions for today's show. All you need to do is to jump in on Facebook, click on that link, answer the questions, and you could stand a chance of winning this awesome Casio calculator. Talking about it, we have a winner from last week's show, and our winner is, drum roll please, Natasha.
We still have to work on those sound effects, hey?
Yes, yeah.
So for the
In the meantime, our
go.
winner is Kumucho Maifo. Congratulations to you, Kumucho Maifo. This awesome calculator is coming your way. So Mindsetters, better enter now because you need this for your exams. But looking at what you guys are saying on Facebook, we've got some few comments. But I like to challenge you guys to send us your questions because we're here to help you guys. We're here to assist you since we're doing revision. So you guys probably have some questions that you have. So make sure that you send them through. On Facebook, there's Doninza. Katleo, actually Moses, saying, just tuned in to my favorite show. Thank you. Welcome. And Mobile Mkonto saying, just tuned in. Thank you to every teacher that is giving us their time to help by helping us. You're doing a great job. So thank you so much. Last one is from Ananias Klobata saying, looking forward to a great show today next to the TV already. A big shout out to you, Ananias. And I hope you're going to enjoy the show. But send us your questions, guys, because we are here to help you. Over to you, Natasha.
All right, great. Glad that you guys are tuning in and you're ready for a revision of trigonometry, which is what we're doing with you guys in grade 10. So we've already done question 1, where we just looked at a basic trig ratio question where you had to draw a Pythagoras triangle and then work out your answers for that question by using the diagram. Now in question 2, very, very common, obviously you're going to be asked trig graphs, okay? You need to know how to draw your trig graphs. Guys, I want to remind you, like for example in question 2, they say sketch the graph of y is equal to minus 2 cos x. When they say sketch the graph, we're not doing point by point plotting. So you're not using your calculator and getting specific values at every single value along the x-axis. We're doing a sketch graph, so that means we are taking critical points and showing those critical points on the graph. Okay, that's what we mean by sketch graph. In this question, you're asked to draw the graph between 0 and 360. So I've just put on an axis here, and let me just take off the remainder of all of these green scribbles. We've drawn the axis there, and we've got it going from 0 to 360. As you can see, I've got some key points on the graph, and we're going to draw the graph y is equal to minus 2 cos x. But what I want you to just remind you of is the graph y is equal to cos x. Because remember, when there's a number in front of the cos or in front of whatever your trig ratio is, that number is going to affect the amplitude of the graph, right? It affects the amplitude of your graph. your highest point and your lowest point on the graph is going to change. And remember, in order to draw a graph where there's an amplitude change, you take your original graph, you take points in that original graph, and you times it by whatever number's in front of the question that they ask you. Okay, so whatever they've changed the amplitude by. All right, so let's just remind ourselves, y is equal to cos x. Now remember, that graph, very importantly, cos of naught. So if we're looking at, that's the point naught, naught there. Cos of naught is 1. So at 1, I'm just going to put a little dot there. All right? And then another key point is that cos of 90, the graph cuts the x-axis. It's an x-intercept, so it cuts the x-axis at naught. All right? So it cuts the x-axis at 90, and the y value at that point is naught. And then cos of 180 is -1. Cos of 270 going back up in the other direction, cos of 270 is naught. And then cos of 360 is 1. All right, so we're going to join those points roughly to get our sketch graph of cos of x. All right, so it goes down to -1, cuts through at 270 and naught, and goes all the way back up to 1 at 360. So that's the original cos of x graph. But you haven't been asked to draw that graph. Hey, you need to draw y is equal to -2 cos x. So in order to draw that graph, guys, you need to times each of your y values by -2. And that's going to be your new cos graph. So instead of the graph being at 0 and 1, we times the value at 1 here by -2. -2 times 1 is -2. So therefore, what are you having? This is a negative, right? So remember, negative y is equal to -2 cos x. As soon as there's a negative on this side, what does it tell you? It's going to be a reflection in the x-axis. So the negative tells us the graph is reflecting in the x-axis, all right? And then the 2 tells us what the amplitude is going to change to. So the lowest point is going to be -2, the highest point is going to be 2. But the negative tells us that that's a reflection along the x-axis, all right? So if I take the point 0, at 0 we know the cos graph is normally 1. I'm going to times that by -2. So now it's going to be, let's just check here. So that's 2 there. All right, so 1 times -2 is going to give me -2. Cos of 90 is 0. So 0 times -2 is still 0. Cos of 180 is -1. So if I times this value here, -1 by -2, I'm going to get +2, right? So it's going to go up to +2 there. Cos -2 cos x, we know that cos of 270 is 0. 0 times the -2 in front there is going to stay as 0. And then cos of 360 was 1. So -2 cos 360 is going to go down to -2. All right. Now, guys, remember we have covered this in a lot of detail previously. So this is just revising the stuff that you should already know how to do. Okay. So now we're just going to join those points up. All right, there you go, and that's your -2 cos of x. So just make this little top bit here not quite so pointy. There we go. All right, it's a bit better. All right, so just a reminder of how to draw this graph. Firstly, we looked at the domain they gave us. They gave us that the domain was 0 to 360. So that tells me I'm starting when x is 0, I'm ending when x is 360. We then took the graph of cos x. So remember, you're not going to show the graph in green. The graph in green was just for us to see how we're going to superimpose, or how we're going to draw this graph of -2 cos x based on the original graph y is equal to cos x. So the graph in green, you will not show it, okay? What we're interested in is -2 cos x. So you can draw the graph of cos x, the one in green, draw it in pencil. rub it off, and then just leave your graph that they're actually asking you for, okay, which in this case was minus 2 cos x. So the graph that we're interested in is just that one. Okay, and the easiest way to get that graph was simply by taking the original cos of x graph, and all we did was we times each of the y values on the original graph by -2, and that gives us this new graph, y is equal to minus 2 cos x. Alright? So guys, they could say to you, well, what is the amplitude of this minus 2 cos x graph? Hopefully all of you know the answer. The amplitude is always going to be whatever is in front of your function without the negative sign. So therefore, the amplitude of y is equal to -2 cos x is just going to be 2. Alright, so they can ask you questions on the amplitude, they can ask you questions on the range, and you've seen before, we've done this in previous lessons, where we can ask you a whole lot of other graph interpretation by putting more graphs onto this one. But it all starts with knowing how to draw your basic trig functions. You need to know how to draw cos, sine, tan. Learn those ones, and then you're simply going to multiply, or if we're doing a vertical shift, or add your values on, and that's how you're going to move your graph around. So you look at the original graph and then look at the graph that they ask you for, and then either multiply by the values if they ask you for an amplitude change, or if it's a vertical shift, you're going to add values on. Alright, but as I said, this is just a revision lesson, so for you that are feeling a bit overwhelmed, it means that we need to do a little bit more revision, because we've covered this in detail over the last couple of weeks. Alright, Abi, at this point, is there any questions on this cos graph?
Not on that question.
Okay.
But I'll
great.
urge the mindseters to send me some questions if there's something that is not clear with them, because I'm busy taking note of their questions.
Okay, great. So then, guys, we're going to move on to question 3 now, which is a 2D problem. Alright. They tell us that ABCD is a trapezium. Remember trapezium, we've covered this in our quadrilateral section. A trapezium is a quadrilateral with one pair of sides parallel. We're told that AB is equal to 4 centimeters. That's drawn on the diagram. CD is 5 centimeters. Sorry, BC is 5 centimeters. AD is equal to 5 centimeters. So in other words, this is an isosceles trapezium. Point E, on diagonal AC divides the diagonal such that AE is equal to 3, and angle BEC is equal to 90 degrees. Alright, find angle ABC. So they're looking for that one. So that's the one we need to find. All the other bits of information they gave you is listed on the diagram. Alright? Now, if we look at the angle that they've asked us to find, we've got angle ABC. You can see that this vertical height BE splits angle ABC into 2 pieces. So what I'm going to do is I'm going to call the one piece of it theta and call the other piece alpha. Alright? So therefore, if I want the whole value of angle ABC, it's simply going to be the sum of those 2 angles. Okay, so that breaks it up into a more manageable portion for me, because I know all I need to do is first find theta, then find alpha, add them together, and I'll get the whole angle ABC. Alright? Remember, the fact that it's a trapezium just tells us that AB is parallel to CD. Okay. Alright. So I'm going to break this into 2 little triangles. First, let's start looking for theta in triangle ABE. So that's the first one we're going to use there. Alright? Now guys, look at what you've been given, okay? We want to find out what theta is. What do we have? Well, I've got the opposite side. We know that BE is perpendicular to AC, so therefore we know that that angle BEA is 90 degrees. I've got the opposite side AE, and I've got the hypotenuse side AB. Opposite over hypotenuse, that's the ratio for sine of theta. So I can set this up. Sine of theta, and this is going to be in triangle ABE. And what I've done, how did I get the theta? I said let angle ABE, let that angle equal to theta. Okay, that's how I got the theta in there. So sine of theta is opposite over hypotenuse. So in my diagram, it's going to be AE over AB. All right. Then we know that AE is 3, and we know that AB is 4. So therefore, sine of theta is 3 over 4. Now, in order to find the angle theta, well, here we've got to use our calculator, right? Because remember, we need to find the angle that would make sine of theta equal to 3 over 4. So we use our Casio FX82ZA calculator, and hopefully all of you have been winning these so often you all have this calculator. So we've got shift sine, we're going to put in our 3 over 4, or 0.75 if you prefer. Alright, remember whenever you're looking for the angle you need to start with shift and then equal, then we get an answer of 48.59. Alright, so the theta part of the angle is 48.59, but now we still need to find, because remember we're not done, we still need to find alpha. Now, what triangle are we going to use, guys? Because all we know is we know that BC is 5 centimeters, but I don't know what EC is, and I don't know what BE is. So how am I going to find any angle in this triangle when I don't have another side? So now we're looking in triangle BEC. In order to find alpha, I need another side. How can I find that other side? Okay, ask yourself, how do you find that other side? Well, if you look at triangle ABE, we know that that's 90 degrees. We have the length of AB. We have the length of AE. So we've got a 90-degree triangle. We've got two lengths. What can we use? Pythagoras, hey? So I can say AB squared, which is the radius squared, is going to be equal to AE squared plus BE squared. And that comes from the fact that that's a 90-degree triangle, so we can simply use the Pythagoras theorem, right? So therefore, we're looking for BE, so we know BE squared is going to be AB squared, which is 4 squared, minus AE squared, which is 3 squared. So I'm going to get 16 minus 9. 16 minus 9 is 7. All right, so therefore, BE is going to be equal to plus or minus the square root of 7. However, remember we're dealing with a distance, so therefore the negative value is not applicable, so BE will just be equal to positive root 7. Okay, because we are dealing with a length. So therefore BE is just root 7. Okay. So now in triangle BEC, alright, so if you look at what you've been given, in triangle BEC, we have now worked out that the length BE is root 7. We are given that the length of BC is 5 centimeters. So therefore, we've got two lengths within this triangle, so we will be able to work with our trig ratios and the fact that this is a 90-degree triangle and work out the angle alpha. All right, so let's get to that. So this is in triangle BEC. Alright, and we're now looking for alpha, so I'm going to say let angle EBC equal to alpha. Also remember in your test on that, if you're going to introduce things like alpha and theta, don't assume that the teacher knows what you're talking about. You need to say which one is alpha, which one is theta, so you need to name your angles accordingly, right? So I'm looking for alpha. What do I have? I have adjacent, I have hypotenuse. The ratio adjacent over hypotenuse is also known as cos. So I can say cos of alpha is equal to adjacent over hypotenuse, which was 5. Again, we're looking for the angle. If we're looking for the angle on our calculator, we need to start with the shift key. So we start shift. In this case, we've got cos, and it's root 7 divided by 5. Right, and that gives me 58.05. So 58.05 is the value of alpha. So I know what alpha is. I know what theta is, so therefore I can work out angle ABC because it's now just theta plus alpha, so therefore angle ABC is going to be equal to 58.05 plus, what was the value of theta? We got there 48.59. We add those together and we get, so it's 58.05 2 plus 48.59, and we get 106.64. Okay, so therefore we now have the whole value, angle ABC, and we did it simply by splitting that question up into two simpler triangles and then working out the value of theta and alpha, adding them together, and we've got the whole angle that we're looking for. All right, guys, I think it's probably time to take a break after we went through all of that information, get all the information, let it sink in before we start our challenge question.
Exactly, but you can still continue with your challenge question if you haven't answered it. It's on the wall, so do check it out. And after the break, we'll also be answering some of your questions. So guys, I saw them. We'll answer them after the break. See you. Welcome back, awesome mindsetters. This is the chance now that you guys are given to ask your questions and also to answer the challenge question. But if you missed that chance, we are giving it to you now. We're going to be answering the challenge question with Natasha, just for you guys.
All right, guys, hopefully you've got some answers for us. I'm eager to see if anyone got it right. AB, you will let us know.
I will.
Guys, as I gave you a clue before, you need to draw a diagram in order to answer this question. And it says, from a window in a building on one side of a street, which is 40 meters wide, the angle of elevation, remember, going up, looking up, the angle of elevation to the top of the building across the street is 30 degrees. And the angle of depression to the foot of the building is 28 degrees. Before we go any further, we're going to draw a little diagram to show us what's going on, right? So let's just take one of those and let's draw a building. Okay, so we've got a building on this side of the street. Okay, not quite what I was looking for. We wanted something a little bit straighter here. There we go. So we've got a building on this side of the street. And then obviously the one on the other side must be shorter. How do we know that? Hey, how do we know that it's got to be not as tall as the one on the other side of the street? Because they said there's an angle of elevation. If they were in the same height, or if this one, the building you were in, was slightly taller, there would be an angle of depression going across to the other building, right? But here, there's an angle of elevation, which means that this building that you are in, all right, that must be slightly shorter. And guys, it doesn't matter if you put the shorter building on the left and the taller one on the right, or vice versa, as long as you do the calculations correctly, all right, you will still get the same answers. Okay, so this is our one building here. Let's put our little windows in. Okay, and on this side of the street, you are standing here. You've got nothing to do. It's a Saturday night, so you decide to look out of your window and measure the angle of elevation, right? So you're looking to the top of this building. And you see that, okay, well, if I'm looking to the top of this building on a street that's 40 meters wide, so that means the distance between the two buildings, that distance is 40 meters, right? Remember, these buildings are perpendicular to the ground. They're not leaning towers or anything like that. All buildings are generally built at 90 degrees to the ground, all right? So, and they've got the same distance apart, all right? So therefore, the distance anywhere between these two buildings will be 40 meters. And the angle of elevation to the top of the building is 30 degrees. So if this is you here, this is your eye, and you're looking up, right? And you're looking out of your window, you look up to the top of this building, and that angle of elevation is 30 degrees. Where does that angle go? We're going to put it in just now. Then, you're so clever, you look down to the bottom of the foot of the building and you see that that angle is 28 degrees. So your angle of depression going down that way is 28 degrees. Obviously, we can't measure any of these things by eye. We need special equipment to measure this, right? Okay, now where do our angles go, guys? Remember, whenever you're putting these angles in, it's always in relation to a horizontal line, a horizontal plane. So therefore, we need to put in our horizontal line. Okay, and that line is the same distance as the distance between the two buildings. So the distance between the two buildings will stay 40 meters all along this diagram. Your angle of elevation from this point here, they said that that angle is 30 degrees. All right, so this here is going to be 30 degrees. And then the angle of depression, so we're measuring again from the horizontal. The angle of depression, you're looking down to the foot of the building, and that angle there is going to be, what did they say it was? It's going to be 28 degrees. All right, so that's your angle looking down, 28 degrees, and the other one looking up is 30 degrees. And we know that the distance between the two buildings is 40 meters. So this here is 40 meters. Now, whenever you deal with a question like this that's sort of cascaded, it's got lots of different parts in it, you need to break it down into manageable pieces, right? So what we've done here, yes, we've drawn buildings. It looks complicated, but it really isn't, because all it is we're working with two different triangles. We've got one triangle with the angle of elevation, and then we've got another triangle with the angle of depression. So we use those two triangles to break this up into a manageable piece. Why would I want to use those two triangles? Remember, you're trying to, if we go on to read the rest of the question, it says here, calculate the height of the building on the opposite side of the street if both buildings are on the same horizontal plane. So if I want the height of the building across the road, all I'm simply going to do is to find this length there, and then I'm going to add it to the length here, and that will give me the total length of the building. All right, okay. So therefore, remember these are parallel, so therefore they have the same perpendicular distance. So in my first triangle, I'm going to say, well, using my angle of elevation to the top of the building, that distance from the top, if you want to even make it a little bit better, you can call these points A, B, C. Again, anything you do, if you're putting these points A, B, C in your diagram, you're going to have that diagram drawn in your answer book so that the teacher can see what is A, B, C. Okay, so A, B, C, let's call this point D. All right, so in triangle A, B, C, what do we have? All we really know is the distance between the two buildings. So from my angle 30 degrees there, the distance between them is 40 meters. We want the height, which is AB. So if I'm looking across, AB is my opposite, and 40 meters, that distance between the two is your adjacent. So therefore I can say tan of 30 is equal to opposite over adjacent. All right, therefore cross multiplying, I'll get AB. So I'm just cross multiplying. AB is equal to 40 tan 30. So 40 times tan 30. Simply put that into your calculator. So 40 tan of 30. And we get 23,094. Alright, so that's the distance AB. We then need to find the distance BD. We're then going to add everything together and it's going to give me the total height of the building AD. So now, in triangle BCD, okay, I can say, well, looking from the 28 degrees, remember we're looking down, it's our angle of depression. I'm looking for the opposite side. What do I have? Once again, it's the adjacent side, so therefore I can say tan of 28 is equal to opposite, which is BD, over adjacent, which is 40. Once again, cross multiplying, I'll get that 40 tan 28 is equal to BD. And then use our calculator, 40 tan 28, 28, and we get 21,268. Alright, so this is equal to 21,268. We're then simply going to add those two together, 21,268 and 23.094 plus 23.094, and we get 44,36 as the distance, or sorry, the height of the building. So 44,36, I think it was in meters. This is the height of the building. Okay, so it's 44,36. Hopefully, maybe some people have this answer.
Let me check.
44,36. Unless I've made a horrible mistake somewhere, no one has the answer.
And no one has an answer.
Do you have any different answers?
Different from yours, no.
Okay, so that means no one's tried it, or they tried it. Do we have any answers?
Yes, we do have 44.36. Yeah, they got it right.
23.094, 21.
There's no one who got a different answer from that one, so well done.
Okay, well done to me.
Well done to you and the mindsetters.
Alright guys, so 44,36. We will obviously post these answers up and the rest of it. And remember, the most important thing here is your diagram. If you get the diagram correct, and remember that when you're dealing with your angle of elevation, your angle of depression, you're always doing it along a horizontal line, because you've got to look down or you've got to look up from a certain horizontal line, horizontal plane. All right. Okay. Are we ready for some questions?
Yes, some questions and comments. Let me start with this comment from Sihle Fortunate Kunene. She says, what a miracle. I never thought that I would understand this because I have been trying it, but now I got it. So thank you so much, Sihle. And thanks to you, Natasha, also for making the magic.
Hey.
Right. First question. Please help me with the 10 graph. That's from Kagalelo Dioka.
All right. Okay, so I am, but I just want to remind you guys, it's sort of like a little shouting at. We have done all of this in lots of detail, guys. So maybe for whatever reason, he or she missed that lesson, but we've gone over all of these graphs in a lot of detail. So that means that that person wasn't paying attention on that day. So even the -2 cos x, I think we had someone asking about how do you multiply to get the -2. We've done all of that in a lot of detail. But I'll go over briefly the tan graphs. And what I just want to remind you guys is that if you are not following along with how to draw these graphs, just please go back and revise. You've got plenty of time still to revise and get this graph perfect. All right, so a couple of points on the tan graph. All right, and hopefully the person that asked the question does remember the key points on the tan graph. On the tan graph, some of the things you need to remember. So if we've got y is equal to tan theta, the period of this graph, how long it takes to complete one wavelength, the period is 180 degrees. The range does not exist because your tan graph goes on infinitely. So y is an element of real numbers. All right. What else do you need to know? Very importantly, on the tan graph, you have asymptotes. Asymptotes, remember the graph is undefined along those lines. Asymptotes, x is equal to 90 and x is equal to 270 if you're drawing a graph from 0 to 360. All right, so we're going to take a graph, draw it from 0 to 360. Okay, and let's put down a very rough drawing of this graph. Okay, asymptotes at 90 and 270. So that means your graph is undefined along those lines. Okay, and I did explain to you before why that is, because if you think of tan 90, think about your special angles. Tan is y over x, and at 90 degrees, the x value is 0. So obviously, if you divide by 0, undefined, you can't do it. So tan of 90, tan of 270, in fact, any little period of 90-degree intervals, it will always be undefined because the x value will be 0, and therefore you have asymptotes at those intervals of 90 degrees. All right, so at x is equal to 90, we have an asymptote. We also have an asymptote at x is equal to 270. All right, so this is 90, and this is 270. So the tan graph does not touch those lines. All right. You also remember a key point on the tan graph is that tan of 45 is equal to 1. All right. You don't know why? Have a look at your special angles. Okay. So I know that at tan of 45, the graph is going to be 1, which let's just say that's there. So therefore, we have a graph going like so. We also have key points at 135. Tan of 135 is -1. And we've got another key point on this side, tan 225. Okay, and you can see that the graph increases infinitely in the positive direction and decreases infinitely in the negative direction. Tan of 360 is 0. And tan of 315 is -1. So again, you're putting those, remember I said this before, sketch graph, you're putting key points on the graph. It's not point by point plotting, right? Okay, so I put in the key points at 45 at each 45-degree interval. I know I have my two asymptotes in. Remember that when you draw your tan graph, it always goes away from the asymptotes. It's never going to actually touch the asymptote, because along the asymptote your graph is undefined. So it approaches the asymptote, but it will never actually reach the asymptotes. Okay, all right, so that's basically what your tan graph looks like in a nutshell, and those are the key points that you need to remember about that graph. Also, guys, just a reminder, when you're doing graphs, do not mix up period and domain, okay? Because we can ask you to draw a graph from 0 to 360 degrees, which is the domain of the graph, all right? But its actual period, like in the case of the tan graph, its period is 180 degrees, which means that's how long it takes to make a complete wavelength. Okay, all right.
Let's take another question from Lebogang. Lebogang says, "Hi Natasha, great teacher, big ups. How do you identify a given trig graph on whether it is a cos or a sine graph? I'm confused."
All right. Okay, so what did you say the name was?
Lebogang.
Lebogang. Okay, that's a good question because they are very similar, right? You know that all of your periods, amplitude on the normal sine x and cos x graphs, they're the same. And so how do you identify it? Well, the shape. The shape is completely different, okay? So if we look at, and I'm just going to take sine x and cos x because they didn't say specifically which sine graph and which cos graph. So if you look at, again, let's just draw a rough axis here. The cos graph, one of the defining features is that it starts off at 1 and goes down to -1, back up to 1. So your cos graph starts at cos of 0, you get 1, and it goes down to -1 and then back up again to 1, right? But one of the defining points, and I mean this is where the graphs differ quite a bit, is where they have the x-intercepts and what happens for them to reach, or at which value they reach their minimum and maximum points. Okay, so they've got completely different shapes, lots of similarities. Period is the same. Your period is 360 degrees for both graphs, and on both of them your amplitude and your range is the same when you're dealing with just your normal cos and sine graph. But look, your pink graph, the shape of your cos graph, it starts at 1. However, if you're looking at your sine graph, okay, the sine graph starts at 0, okay? And guys, this you really just have to know by practicing a hell of a lot how your graphs are going to look. There's no other way for you to get around knowing what the graph is going to look like. You're just going to have to practice, practice, practice until you get this graphs perfect. All right, that's all you can do. The key points on your sine graph, you know that sine of 90 is 1, whereas cos of 90 is 0 degrees. So you look at those specific different points on the graph, and they have different shapes. Okay, so they cause different shapes. I think my graph's going to be slightly skewed, but let's have a look. So at 90, we've got 1. 180, it hits 0, 270, minus 1, and 360. So there we go. Cos graph is in pink, sine graph is in blue. So if you look at those two images, you can see what I'm saying to you. They start at different points, right? They both start. The sine graph starts at 0, the cos graph starts at 1. At cos of 90, your graph is cutting the x-axis, and then sine of 90, you're reaching your maximum point of 1, all right? So there's completely different shapes for the two graphs. And we're going to ask AB what is so hilarious, because he is just ripping up in the studio.
No, I'm excited about the question and how you are explaining it. I think it's more simpler now to everyone. It's a revision, but I felt like it was the starting of the whole lesson.
Yeah. All right, guys. So as we were saying, it is a revision lesson, but you need to remember all of your original tan, cos, sine graphs in order to apply all the changes that you're going to see later on, amplitude changes, vertical shifts, and the rest of it. All right.
Awesome. Well, unfortunately, we have to end it there, Natasha. Thank
Okay.
you so much. As they always say that ichaba lethu nje lixesha. But that's
Okay,
where
I'm
we
not
end
even
it.
going to try that.
Our problem is always time. We're always running up against time. But thank you so much for your time. Really
Pleasure.
appreciate it.
Thank you guys for joining us. Good luck with tests and exams coming up.
Indeed, into ngapheliyo iyahlola. Mindset is we do have some information about our help desk on facebook.com/learnextra. If you're having some questions, go to our help desk. All the information is on Facebook. We love you and peace.